Start recording. There we go. What are the 3 things that you need when you are recording any measurement? All right. We need the units. What is a second thing that we need, Matthew? We need an estimated digit. 1 estimated digit. And we need a third thing as well. What else do we need? Yes? What you're measuring, yes. And you said something else at the end there. Yeah. Okie dokie. Now, what if you are exactly on a line? What would you normally have to do? Tell your partner. If you're exactly on a line. So let's say that we had this red thing and we are measuring in centimeters. Tell your partner what that measurement would be for the red object. Let's call it a, what should we call it? Should we call it a stick? Okay, we're going to pretend that that is a red stick. Tell your partner how you would record that measurement. What is the first thing we would write down in that measurement? Thank you. Which one of these 3 things would be the first thing that you write down in your measurement? Do you write down the units first? Do you write down the estimated digit first? Or do you write down what you're measuring in an equals sign first? What you're measuring and an equals sign. So this one comes first. So what are we measuring? We are measuring a red stick. But we can't just say red stick, because if I just say red stick, am I measuring how long it took the red stick to fly across the room? Am I measuring the mass of the red stick? What am I measuring about that red stick? Am I measuring, you guys get to put up your hand when you hear the correct one. Am I measuring its volume? Am I measuring its mass? Am I measuring its temperature? Am I measuring its length? See, you guys know, you're just being shy today. So we're going to write down length of red stick equals. And now we're going to look at, do we know for sure the actual number of centimeters? Like, can I go to the ones position? Is the ones position a known digit? Like, obviously, this has to be somewhere between 1 and 2. Yes? Am I sure about that one? Yep. So we're sure about that. This is 1.1, 1.2, 1.3, 1.4, and then this is 1.5. So what should I be writing for this? What should come after the decimal place? 1.4. Now you're going to get to vote on this. Should I be writing that as A, 1.4, B, 1.40, or C, 1.400? Tell your partner what you think. And we're going to vote using, this is the letter A, okay? So if you put your fingers on your palm and you put your thumb beside your fingers, that's the letter A. If you want to vote for B, you're going to put your palm up and you're going to put your thumb on your palm. That's the letter B. And if you want to vote for letter C, you're going to just make a C with your hand. What would you like to vote for? You would like to vote for B. And it's okay. If you don't know, you can be like, I don't know yet. Okay? So most people are voting for B. That is indeed correct. Because are we unsure about the 4 or are we sure about the 4? We're sure about the 4. Nobody's going to be like, oh yeah, I think it's 1.5. Does anybody think it's 1.5? No. Anybody think it's 1.3? No. So we're sure it's 1.4. What about that 0 though? Is everybody 100% convinced that it's 1.40? Could it be 1.41? Yeah. Could it be 1.39 maybe? Well, it's hard to say, you know, like I've made this really big, but if these were really centimeters, it would look more like that. Could you tell if it's 1.40 or 1.39? Not really, okay? So yes, if everything's blown up big like this, it's easier to tell, but yeah, we're not really sure. So it's going to be 1.40. We can't go past there because that is our one estimated digit. Okay. So in any measurement, the final digit is always going to be estimated. Now, how many of you have done significant figures before, say in physics? Okay, so like maybe half of you. So half of you are going to be like, okay, this is really easy, except for then we're going to throw a little bit of extra chemistry stuff. And so yeah, we'll need to pay attention. So we're going to be on page 68. Whoops. So the concept we're dealing today with is significant figures. They are also known as sig figs. You can also, because I get really lazy, because even in grade 12, I have to mark whether people have done their significant figures correctly. So you can just write it as SF, and everyone will know you're talking about the number of significant figures. And sometimes you'll even hear them referred to as significant digits. Okay? Significant figures, significant digits, it's all the same things. So significant figures are used for measurements. Okay? We don't use them if I was saying, how many how many pencils do I have? How many pencils do I have? Okay, hello, everybody. How many pencils do I have? Now, is that a guess, or have we just counted them? We've just counted them. So have we made any kind of measurement or estimation? No, we're not estimating, we're not measuring. So this doesn't actually have significant figures, or you could say it has infinite significant figures in that you could say it's 3.00000000000 all the way to an infinite number of zeros, because this is an exact number of pencils, okay? So when we count things, we are not using significant figures. When we are making a measurement, that's when we're using significant figures. And remember, when we're making a measurement, we always want to have that one estimated digit, yes? So it's going to be all of the known digits plus that one estimated digit. And one of the things we get good at in science is counting up the number of significant figures, okay? Significant digits. Another way of saying that, if we don't want to say the known digits, we can say the certain digits. Okay, so we have all the certain digits plus the one uncertain digit, and the uncertain digit is the estimated digit. So if I asked you to define significant figures, you could either say all the known digits plus one estimated digit, or you could say all the certain digits plus one uncertain digit. That is the definition. So, last day, you might have made this measurement. You look at this and you say, oh, that's probably 6.7, or maybe it is 6.6, or maybe it's 6.8. I have one digit that is certain, and I have one digit that is uncertain. So how many significant figures are there in all? 2. Would this be an okay way to write a measurement? I would like you to critique this measurement here that I have boxed in blue. Tell your partner, is there anything wrong with that measurement? Is there anything missing from that? Rajan? Yeah, we would need to write length of pencil equals. All right. Here's a more precise ruler. And here we have 6 centimeters, here we have 7 centimeters. What I would like to know from you now is, should we be estimating, should I have this as 6? Should I have this as 6.7, 6.70, or 6.700? A, B, C, D. So you get to vote for either A, 6, B, 6.7, C, 6.70, and if you want to make a D, you put your pointer finger up and you make a circle with the rest of your fingers, and that's the letter D. What do we like? Do we like A, B, C, or D? 5, 4, 3, 2, and you get to vote. And if you don't know, you get to go like this. Do we need another minute to think? Because I got people who aren't voting. So what we have to ask ourselves is, are we sure about the 6? Is the 6 a for certain digit? Yes. Are we sure about the 7? Is the 7 a for sure digit? Yes. Now, we have zoomed in super close on this, but what if I made it look more like a real centimeter? Are we absolutely 100% certain about that about that 0 in the hundredths position? No. Okay. So that is that 0 there is our estimated digit. And if that is the case, how many sig figs? How many sig figs in 6.70? Hold up your fingers if you think you know the number. 3, absolutely. Okay, so that 0 is significant because that is our uncertain digit. Excellent. What would you measure this thing as? What would the length of this object be? Sorry, I need to show you the 1 and the 2. Please tell your partner. Tell your partner which of these you think are okay. There might be more than one good answer. Okay, what we're going to do for this one is you're going to put your thumb up if you think an answer is good. You're going to put your thumb down if you think an answer is not good, and you're going to put your thumb in the middle if you're not sure about an answer. Okay? Do we like A or do we not like A? Okay, A is thumbs down. Thank goodness. Okay, how about B? Thumbs down on that one. C. Yep, it's not 7. How about D? Also not okay, even though this is 0.8. What's missing from that one? The estimated digit, another sig fig. How about E? Yes, E is okay. How about F? Yes, F is okay. How about G? Nope, because we already have our uncertain digit here and here. Now, just before we carry on, I want to make sure you guys all know your place values. What place value is that 0? That's the ones. What place value What place value is that 8? The tenths. Or if you wanted to write it, you would say it's the 0.1s, but it's the tenths. What position is that first 0 after the 8? That's the hundredths. And this one is the thousandths. Okay? So our uncertain digit is in the hundredths position. How many ones do we have? How many ones do we have in this measurement?
0.
We have none. So has our number actually started yet? When we are in the ones position, have we actually started doing any measuring yet? Or are we just like, I don't have any ones? We're just like, I don't have any ones. Okay? So when we write this, we have either 0.80 centimeters, and this has 2 sig figs. This 0 here just tells us that our measurement hasn't started yet. In other words, that 0 right there, the highlighted one, is just a placeholder. It is not a significant figure. Is that okay? So if we have zeros that are just like hanging out at the front of a number, they are not significant. We're going to skip this part. I think I got really carried away with this, but I actually did try and make, like, each of these objects is actually slightly different size from the other ones. I don't know if you can see it, but it just points out that 8.80 is uncertain. Now, I should actually mention this because this is something, if you go to study at university sciences, you should know that the term error in science does not mean mistake. Error, mistake, not the same thing. A scientific error, not a mistake, it's just a difference between what you observe, the observed value, and what the true value is. So if they get you to do error analysis in a lab in university, you're not going to say, oh, my errors, I forgot to record an extra digit. That would be a mistake. Yes? The error here (0.80), there is plus or minus 0.01 error. So like that's the margin of error. Have you heard the word margin of error? Okay, so that's the margin of error. 0.01 error in this measurement. Okay, because this digit could be as much as 0.01 higher or 0.01 lower. Does that make sense? Yeah? No? Okay. I could have said that this measurement, instead of saying 0.80, I could have said that it is 0.81. Yes, of course. Or I could have said it is 0.79. Right? If I look at that, and let's say it was small like this, and I'm doing my best, I'm guessing that it is 0.80 centimeters. It could actually be, in real life, it could be 0.81. Okay? And in science, that's what we call the margin of error. Okay? So if I guess that it's 0.80, but in real life, like if there were some magic way that I could know exactly what it was, if in real life it was 0.81, that's the scientific error. It doesn't mean a mistake. It just means that our eyes are not perfect. Our measuring tools are not perfect. Error in science really means that we cannot be perfect in our measurements. Does that make more sense? Cool. If something doesn't make sense, and I ask if it makes sense, don't nod if it doesn't make sense, because that will never get it clarified for you. If you're just like, I don't want to be the one to shake my head no. It's always best to get things cleared up. Okay. Now, this here is a black diamond thing. What does black diamond mean? It means it is enriched. So this is, if you want to just like put your head down for a minute, if you're not interested, you can take a little nap. This is what we call the uncertainty, okay? And the uncertainty is basically that margin of error. This is on our next page, page 70. So our length is 0.80. So our uncertainty is in the hundredths position. And if you want to, when you're recording your measurements, you can also record the uncertainty. Okay? And all you do is you say plus or minus 1 of whatever your uncertain digit is. So if my measurement was 7 centimeters, I could say that it is plus or minus 1 centimeter. If my measurement was 5.3 centimeters, my uncertain digit is the 3, so I could say plus or minus 0.1, because that is in the 0.1 position. Okay? Yes. Which one where? There? Position. Yes. I'm sorry, it didn't turn out very well, did it? So the uncertainty is in the hundredths position. Yeah, because here we go, we've got our tenths and then we've got our hundredths. Yeah. So if you choose to, when you are recording measurements, you can use the uncertainties. Now, here's some mistakes students often make. What is wrong with this one here? Tell your partner, what is wrong with our uncertainty in the red box? That 0, that hundredths position is our uncertain digit. But what position, this is the 100ths. What position is that 0.1? The tenths. So if you do choose to record an uncertainty, you have to match your uncertain digit with your uncertainty. They have to be the same position. Okay? These must be the same position. What's wrong with the one in the green box? What's our uncertain digit? It's in the hundredths position. Where have we put our plus or minus? We put it in the tenths position. So again, they don't match. If you're finding this confusing and you're like, I don't want to learn this, don't worry, this is the enriched part. Yes? These guys don't match. I've got a hundredths and a tenths. Here's one that's a little bit different. What's wrong with the one in the blue box? Yes. We're missing centimeters. We have centimeters here, but we are missing units. So you would need to write centimeters. So if you are writing uncertainties, you have to put centimeters at the end. This would be now okay. This is now okay. Or you could write it like this, 0.80 plus or minus 0.01 centimeters. You can do it that way also. You can write the centimeters twice, but you don't have to. But it does have to come at the end. Okay? So this one here is optional. Okay, so it's okay to have it twice. But this one here is mandatory. But like I said, if you're not interested in doing that enriched part, it's totally fine. Okay? Okay. We actually already talked about this, so we're just going to skip over this. And we're going to take a look at all of our zeros. So this is at the bottom of the page. Technically, you do not need to know the term leading zeros as long as you know where they are. Leading zeros are zeros that are on the left of non-zero digits. Okay? So I look here and I say, these zeros here are to the left. Of non-zero digits. And what did we say about those zeros? Those zeros just tell us that our number hasn't started yet. They are just placeholder zeros. They are not significant. So zeros to the left of non-zero digits are never significant. Never significant. Now I'm going to let you know right now that I'm going to circle our uncertain digit. Okay? This is our uncertain digit. This is our uncertain digit. And if you know that these zeros at the beginning are never significant, if you're counting your sig figs, you go not significant, not significant, not significant. Okay? Now I hit a non-zero number and I say, all my non-zero digits, obviously I've made some sort of measurement, that's significant. So I say significant, significant, and here's my uncertain digit. So that's 1, 2, 3 sig figs. Okay? So this one here is 3 sig figs. And either tomorrow or Monday, we're going to be learning a little bit about scientific notation and sig figs, so you can see what we've done is if we write this in scientific notation, and don't worry if you haven't learned it yet, we will learn it. These zeros here disappear when we change the number into scientific notation. So that shows us that those digits are actually meaningless. They were just placeholders, okay? Now, once again, I have zeros that are to the left of non-zero digits. So are these significant zeros? No. So I say not significant, and now I have significant. And once I start counting significant digits, I don't stop until I hit my uncertain digit. Okay? So I say this is certain, this is certain, this is certain, this one is uncertain. So that's 1, 2, 3 certain plus 1 uncertain gives us how many sig figs? 4 sig figs. So once you start counting, don't stop until you get to your uncertain digits. So this number here would have 4 sig figs. Yes. Why is it 4? Okay, so we have 0.260.0. Okay. How many uncertain digits are we allowed? 1, and it's our last one. So this one right here is our 1 uncertain digit. That means that all the digits in front of that 0 are certain. Unless they're placeholders. Unless they're placeholders. So these two zeros here are just telling us our number hasn't started yet. So these two are just placeholders. So zeros to the left of non-zero digits are always just placeholder zeros and we don't count them. Yes? The last number is always going to be your uncertain digit unless there is no decimal in the number, and we'll talk about that in a few minutes. Okay? If you have a 0.4, then the 4 is your last digit. So as long as there's a decimal in the number, your last digit is always the uncertain digit. Okay? It's a good question. So these are placeholders. Your last digit is always your uncertain digit. Yes? Yeah. And what that means is that if all the digits in front of your uncertain digit are significant, that means that this, or are certain, that means that this 2 is certain. This 6 is certain. This 0 is certain. And our significant figures are all of the certain digits plus the 1 uncertain digit. So we have 1, 2, 3, 4. Kind of okay? Yeah? Okay. And if you're not getting it just yet, don't worry. We're going to go through a whole bunch of different examples so it becomes clearer. Okay? So those are our zeros on the left. All right, let's take a look at this beaker here. Could you please give me a measurement for the volume of liquid in this beaker? Please write down a measurement and then check with your partner and see if you got the same thing. So for example 5, write down what you think your measurement is. Can we all agree it's 60 something? 60 how much do you think? 61? Could anyone argue that it's 62? Yeah, it could be. It could be 62 because this right here is 70, right? So it could be 62. Yeah. This is where you could do a plus minus thing. Exactly. So if you wanted to include the plus minus, that uncertainty, you could say it's 61 plus or minus how much? You're going to choose your ones position because that's your uncertain digit. And you're just going to say one of those. So you're going to say, I'm in the ones position, so it's going to be plus or minus 1. Remember that plus or minus is optional. You don't have to do it. Do we love this measurement that I have made here? Yes. I love some parts of it, but there are other parts that I don't love. Rajan? I need a unit. And hopefully every time I give you a device, it will have a unit on it. If it doesn't, you can feel free to ask me. I think I've gone through all the workbooks and made sure everything has a unit on it, but if I'm missing one at any point, just ask me. So in this case, our unit is milliliters. Are we thoroughly satisfied with that measurement now? So close, but not quite. There are 3 things you need in every measurement. Yes. We need to have what we're measuring. So in front of this, I'm going to put an equal sign. What are we measuring? We're measuring the volume, and we're not quite sure what that liquid is. So you can just say volume of liquid. right? If you don't know what the liquid is, you can just say, it's some liquid, volume of a liquid. How many sig figs in that number? 2. We have 1 certain, and we have 1 uncertain. We're going to try our next beaker over now. Okay, so now you're looking over at this beaker here. Not a very good measuring beaker, but give it a go. See what you get. Here? What are we looking at?
Over the 100 milliliters.
Over the 100 milliliters. Oh, under here, you mean?
No, the other one. Just the bottom 100 milliliters.
Here?
No, the other one. Yeah, you see where it says 100 milliliters?
Oh, it says boro 3.8. That just means it's borosilicate glass. You can just ignore that. Okay. No worries, no worries. I didn't even notice it. My brain just filtered it out completely. So you can just ignore that part. And what I'd like you to do is I would like you to make the measurement for this one and then compare with your partner, see what they got and see what you got. So if you have one who's the same uncertain, we're asking, I appreciate it. Okay, I'm going to give you some options for this one. Is this volume here 50 milliliters, 60 milliliters, 60 with a decimal milliliters, 60.0 milliliters, and you get to choose A, B, C, or D, but take a moment to discuss with your partner before you commit to voting. And there might be more than one answer.
Okay.
Okay, actually, I'm going to have you vote the thumbs up, thumbs down again because there are more than one possible right answer here. So how about A? Do we like A as a possibility? I've got 3 people voting. What do we think about option A? I've got 4 people voting. Hello. 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 We're thinking about option A and we're going to vote either we like it or we don't like it or we're not sure. Okay. Option A, 50 milliliters.
I don't like it.
Okay, we're split. We've got some up, some down. All right. How about B, 60 milliliters?
Yeah.
Okay, got lots of thumbs up on B. How about 60 with the decimal milliliters? And it's okay to say, I don't know. You can be like, what the heck is that decimal about, Ms. Spence? I just don't understand. Because at this point, you might not, right? If you haven't taken physics yet. Okay. And how about 60.0? Yeah, that one is way too precise, right? We've gone to way too many decimal places because how could we possibly know that it's 60.0? There's only 100 milliliter marking on here, right? Okay. To be honest with you, either of these are okay. Okay? Now, and this is because in science, a decimal has a specific meaning in a measurement. A decimal in the measurement means that zeros to the right of non-zero digits are significant. So what that tells me is that if there is no decimal, zeros to the right are not significant. So if there is a decimal, zeros to the right are significant. If there's no decimal, zeros to the right are not significant. So what that means is that if we have a decimal, our uncertain digit is the last digit, okay? So if I have a decimal, like in C, my uncertain digit is the last digit. But if I do not have a decimal, my uncertain digit is my last non-zero digit. That decimal has the magic power of making zeros on the right-hand side significant. Okay? If you want to think about it like that, if that helps you remember it, you can think about it as the magic decimal. The magic decimal makes zeros on the right-hand side significant. If that decimal is missing, do we have that magic power? If there's no magic decimal, do we have magic? No. So zeros on the right are not significant if we do not have the decimal. Now, this can be a little confusing. So we're going to look at a few things here, okay? Okay. So this. So here we go. We have 60, and there's no decimal. If there is no decimal, this 0 on the right, is it significant? The answer is no, it is not significant. So look, no decimal, not significant. So this 0 here, not significant. No decimal, not significant. So who is our uncertain digit in that 60? There's nothing else left except the 6. So that is our uncertain digit. And in this case, we have 1 sig fig. And in fact, if you wanted to write this with an uncertainty, this may or may not help it make sense to you. Up here, we could go up here and say, yeah, let's go with that 60 milliliters. I could say the volume of the liquid is 60 plus or minus 10 milliliters. My uncertainty is in the tens position. So my plus or minus is also in the tens position. And if you're feeling like today this is not making 100% sense to you, remember we are at the end of a fairly long block. Be patient with yourself. We'll do a little bit more tomorrow. Okay, this one is the hardest rule. The zeros on the right are the trickiest. Now, let's go down here and say, what if instead of writing 60 with no decimal, what if I wrote 60 with a decimal? Then I say, oh, I have the magic decimal. What does the magic decimal do? Tell me apart. What does the magic decimal do?
Magic decimal.
The magic decimal makes zeros on the right significant. So I look at this and I say, I've got a 6, so that's definitely significant, right? My 6 is definitely significant. How about that 0 that I've highlighted in green? Is it significant? Yes. I say, yes, I have a decimal. So yes, that 0 on the right is significant. And we only have a few minutes left, so what I'm going to do is I'm going to take you right now to page 75, and we're going to look at the summary. Even though we're not quite at the summary yet, we're going to go to page 75 and look at the summary. So how to tell if your zeros, if you should count them for significant digits. And the little mnemonic device, the word mnem is Greek for memory, so that's a memory aid. You don't have to know the word mnemonic device, you can just say it's a memory aid. The memory aid is NIM, which stands for no, yes, maybe. No, yes, maybe. Zeros on the left. That's like those zeros right there. Are they significant? No. If I have zeros that are sandwiched in between, that are in the middle of a number, so zeros in the middle, yes, those are significant. So no, zeros on the left, zeros in the middle, yes. And then zeros on the right, the M stands for maybe. So zeros on the right. And who determines if that maybe is yes and if that maybe is no? The magic decimal. So we ask ourselves, decimal? And in this case, there is a decimal. So we say decimal, yes. Significant?
Yes.
Yes. So for this question, if we had to say how many significant figures, we say that the zeros on the left, I'm going to highlight those in yellow, those are not significant. So I don't count them. I don't start counting. And then I hit some non-zero digits, so those are certain, or sorry, those are significant. And zeros in the middle are significant. And non-zero digits are always significant. And those zeros on the right, remember we said decimal yes, so significant yes, so those ones are yes. How many significant figures in this number? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 sig figs in this number. Let's try number 14. Oh, look. There are no zeros on the left, so we don't have to worry about them. We do have zeros in the middle, and zeros in the middle are yes. And then we have to say we have those zeros on the right, and those ones are maybe. And so we say, is there a decimal? Yes. Therefore, is this zero significant? Yes. So how many sig figs in this number? 1, 2, whoops, I should have started over here. 1, 2, 3, 4, 5, 6, 7. We're going to ignore that little sentence part because we have like 3 minutes left. How about this one? 700.0. Are there any zeros on the left? Nope. Are there any zeros in the middle?
No.
Nah, there's nothing in between. There's zeros on the right. It's a tricky situation, but there's a decimal, so it doesn't matter. Because the decimal says, yes, those are significant. Okay? So how many sig figs? 4. Oh, here we go. 8,800. No decimal, no zeros on the left, no zeros on the middle. I've got zeros on the right. So when we have zeros on the right, we ask, is there a decimal? No. So are those zeros significant? No. So these are not significant. And so therefore, how many sig figs in that number? 2 sig figs. Okay? So if you can remember no, yes, maybe, and then you say decimal no, significant no, decimal yes, significant yes, then you are golden on counting your sig figs. So for homework, I would like you to do on page 77. Actually, I would just like you to do page 77 and study for your accuracy and precision quiz. Don't be shy about asking for clarification if there's anything about accuracy and precision you don't understand.
No,
And if anybody wants to redo their previous quiz, I'm here tomorrow during Flex. If you want to drop by after school today, you could drop by after school today. Alrighty?
I'm sorry. Yeah.
So often. I have one. Yeah. And I have probably 7 to 10. Yeah, actually, most people like. We're not, I don't do it. Thank you. I'll see you.
Oh, this one.
Never mind, you don't have to. No problem.
This was helpful? You're good? All right.
Oh, no, this.
Okay.